Good morning, guys. Okay, first of all, I just want to give you some tips, and we're going to go through the notes, and then I'm going to start working the examples. Remember, this is the fancy stuff from the book, but you have to flip the sign if you multiply or divide by a negative. This is from earlier, like chapter 2 or something like that, when we did inequalities. But if you have a negative before the y, you're going to have to flip the sign in the end, and I will show you an example from that in your book. Also, if you see in the word problem it says they want or they can spend no more than $200 or something like that, it's going to be less than or equal to. If it's like they want to make at least $350 at the concession stand or something of that nature, it's going to be greater than or equal to. This is going to help you set that up because you're always going to have two things like hamburgers and hot dogs, or adults and children, or daisies and tulips, whatever. The first thing is always your x, and then you have the y. You're going to add whatever y, and that's going to be greater than or less than whatever amount they give you. Remember, with word problems, money goes with money, or pounds would go with pounds, so you try to keep all the units the same. Okay, and we'll get more into that once we get to the examples. But I wanted you to have this to look back on. Now, going through 5.5, we're going to tell whether the ordered pair is a solution. And remember, an ordered pair is always in the order x and y. I know I've been saying that. We've been working with this for several chapters, but bears repeating. I'm so sorry, y'all. I'm super tired. Okay, so, for example, if I have 7, 3, and I want to check to see if it's a solution for the inequality y is less than x minus 1, then I'm going to you plug in the first number where I see an x, the second number where I see the y. So, it would be 3 is less than 7 minus 1, which 3 is less than 6. That's true. Or 6 is greater than 3. Whichever way you want to read it is fine. Remember this, it always eats the bigger numbers, so whatever number it's open to, you're going to say that one is greater. And we always point to the little number. We make fun of it because it's little bitty. So we always point to the smaller number. So if it's pointing to a number, you say that is less than. If it's open to the number, you would say that number is greater than. In short, plug it in and solve. If you're graphing, you have to put it in y equals. Then you're going to plot the y-intercept and use the slope to graph. Now, you graph the boundary line, and all that is saying is is it dashed or is it solid? And you know that because I think I did that yet. So for this, it's going to be dashed, and if there's a solid line under it, it's going to be solid. Then you just shade in the direction of the arrow. If it's pointing to the right, you shade down to the right. If it's pointing to the left, you're going to shade up to the left. But if it's in y equals, you can always shade the direction of the arrow. And then you just, if you have to choose two solutions that work or two that don't or something like that, anything in the shaded will work. So you just go over and find one of those dots that you could put. So anything in the shaded would work. Anything outside of the shaded will not work. Now, there are a couple type of word problems in here. First of all, you need to label your variables. That's what I said here. Then you set up the inequality. Then you graph it. All right. Now, let's look at this example. Okay, so let's look at this. Sarah can spend at most, so this tells me, remember, we talked about that up here, no more than or at most, same thing. It's going to be less than or equal to, okay? Because she can't go over it, so she has to be smaller than however much money she's given. $7.50 on vegetables for a party. So I'm going to go ahead and write my inequality. I know I wrote that here, but if it says no more than, I've got to do less than or equal to the $7.50. Okay? Now, broccoli costs $1.25. Well, that's my first thing I've seen. And carrots cost 75 cents. So there's my Y. So I have $1.25x plus 75 cents Y has to be less than or equal to $7.50. Now, you graph it. Now, the thing is, because I have these decimals, like with money, that's going to be a lot of decimals and you can't really graph decimals. So if I want to get rid of all my decimals, you would multiply by 100 to move the decimal over. But if you'll remember, if I will multiply the entire thing by something, we did this in elimination when we were trying to get the variables to cancel out, you can do that. So by multiplying the whole thing by 100, it's going to give me 125 even. That's much better. Okay. Now, I've done the rest of the work already. I did this. Now, you won't always have to do that. It won't be in decimal form, but if it is, I would suggest you doing that. Now, to do so, I've got to put this now in y equals. So now I'm going to subtract the 125 from both sides, which gives me 75y is less than or equal to. Y'all cannot stop yawning, I'm sorry. Negative 125x plus 750. Now, I've got to divide both sides by 75, normal stuff. And this is going to be like 1.66 repeating. So when you do that, you're going to hit math enter in your calculator to get it into a fraction, which is what we want for slope. So y is less than or equal to negative 5/3 plus 10. So now we're going to put a plot at the 10 and go down 5 over 3, down 5 over 3, down 5 over 3, and plot that until we can't anymore. And it's a less than, so we're going to shade to the left. Going to shade down, backwards. So when you do that, if you have to give any combination that will work, now you can't have negative combinations. So you're going to have to do everything. You're going to have to do everything that's positive, right? So I have 10, and I go down 5. 1, 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. I can stop because I know I can only have a positive amount. Even though technically this line keeps going, okay, I only have to look what's in here because I can't have like negative vegetables. I can only have up to 0. So that is, now 0, 0 is a solution. I can have, if I don't buy any broccoli or no carrots, I'm going to have $0 spent, and that's fine because that's under my budget. But I'm only going to look right here, even though you're shading all of this. You're just going to want to look in the positive. don't know what's going on. Okay. So, let's go back here. I'm going to clear that. Just wanted to walk you through it. Okay. Now, to write an inequality from a graph, that's going to be given down here. Okay. You have to find the y equals. There we go. I'm going to try to put that all on one thing. You're going to find the y-intercept, find the slope, and then you can put it in that y equals mx plus b form. You're going to see if it's dashed or solid, and instead of having the equal sign here, you're going to switch it with if it's going down, and do less than, look at the dash or solid and put the sign that matches it, and then see what matches. But you're going to point it in the way that it's shaded. Okay. Now for the systems, that just means two or more that you're seeing how they interact with each other. Tell whether it's a solution, just plug it in, just like we did, and shade your graph. All right. And then anything that can be found where the overlapping is, it's a solution. And sometimes you don't even have to graph because you can just plug it in like we did up there wherever you see x and y. If it works for the first one, just try the second. To solve it, you're going to put each one in y equals like we did up there. So put the point on the y-intercept and use the slope to graph. And then you shade in the direction of the arrow and where they overlap. If they do, sometimes it might be no solution like this, then you write it down. If they're parallel, these are the three ways. Parallel just means they have the same slope, so the x will be the same. Then there's three different choices you can have, and I wanted you to have the chart on your notes so you can look at it, but it's on page 368. And here's your vocab I want you to study before the test. Okay, now let's get started. Okay. So, Dirk is going to bring 2 types of olives to the honor. I gotta get my pen up here now. Dirk is going to bring 2 types of olives to the Honor Society induction and can spend no more than, that goes back to the hint, he can spend no more than, so it has to be less than or equal to $6. Green olives cost 2 per pound, that's my first thing. And black olives, which we're always adding this, cost $2.50 per pound. Now, since it's only one decimal, I'm going to try to solve it the way it is. But if I see that it's an issue, I'll multiply this whole thing by 100. Okay. So here's the thing here's the inequality to describe my situation. Now I need to graph it. So first of all, let me think here. I'll put this in, let me just go on and see my calculator. Well, let's see. All right. I'm trying to reduce this in my head. Hold on. Okay, so I'm going to leave this the way it is. So I'm going to do negative 2x minus 2x, just like normal. Then I'm going to have 2.5, because I can drop the 0, y. It's less than or equal to minus 2x plus 6. So I divide by 2.5, divide all of this by 2.5. And this is going to give me y is less than or equal to. This is going to be 0.8. Well, I know that 80 over 8 over 10, and then that's going to become 4/5. So negative 4/5. You're going to do math inner, but I had to do that in my head. Okay, and then 6 divided by 2.5 is 2.4. Now, I have, let's see. So give two combinations of olives that he could buy. Now, I would put this in your calculator. Okay, so I put negative 4/5 x plus 2.4, and then I would graph it. Now, if you've watched my graphing videos, then you know that you can go right before the y to where it's flashing, and you can shade it down. So you're going to hit enter, and then shade down. And then you can pick any one of those that are legitimate combinations. Now, if you go to second graph, I'm going to call you guys here in a minute once, before the test to make sure you can do it in your calculator. So you have second graph. That's going to give you the table. And you can go pick two solutions that would work and two that wouldn't. Remember, this is only positive. So I'm going to try to briefly graph this by hand, but you're going to need to do it in your calculator. So if I have y is 2.4, right? For here, it'd probably be 240. I would probably go ahead and, if I see a decimal, I'm just going to multiply everything by here 10 and just kind of do it that way. But I would put this in your calculator and find the combinations from that. Now, write an inequality to represent each graph. First of all, I need to find my slope and my y-intercept. My y-intercept is -1. So if my y-intercept is -1, my slope is, let's see, 1, 2, 1, 2, 3. So my slope is 2/3. I'm going to put that in y equals 2/3 x. And now I'm shading to the left. I'm shading backwards. So since left is less, I wrote that up there. I'm going to go, -1. And since I am shading left, I know I'm less than. And since it's dashed, I don't do anything else. Like over here, my slope is going to be negative because I'm going down. So it looks like I'm negative down 1 over 1, 2, 3, 4. So my slope is -1/4 x. And my y-intercept is 3. So I have y. Now this is a solid line, and I'm going greater than because I'm going down to the right. I'm going to the right of the line, not to the left, which is back of the line. So this is greater than or equal to -1/4 x plus 3. Okay? Now let's move down. Stephen wants to buy yellow tangs and clownfish for his saltwater aquarium. My father-in-law loves fish. He's actually bought these fishes before. So, yellow tangs is going to be X, clownfish is going to be Y, because those are the first two things I'm given. He wants to spend no more than $77, so whatever it is going to be less than or equal to $77. At the store, yellow tangs cost $15 each, and clownfish cost $11 each. Write and graph a linear inequality to find the number of yellow tangs and clownfish he could purchase, and then name a solution that's not reasonable. Excuse me. So, I'm going to minus 15x, minus 15x. So I have 11y is less than or equal to negative 15x plus 77. Let's just be a plus, not a 4. Okay, divide by 11. Now, this cannot reduce, so it stays y is less than or equal to negative 15 over 11 plus 7. So you're obviously going to want to do that in your calculator because I go down 15 and over 11 each time. And then whatever's not shaded, I would scroll up, and we're going to go over this over our FaceTime today. Okay. And the battery's dying. All right. Okay, so we're going to look at this test prep here because these are examples of what might be on your test, which I know it's on Google Forms, so this is totally different, but we're going to do our best here. Let's write the inequality. Here we have a 0, so I know that I just need to find my slope because I have my y-intercept is 0. All right. It's thundering out there. So I have that it is down 1 over 1, down 1 over 1. So I have y, this is dashed, and I'm shading to the left, so I'm getting smaller because I'm going to the left. So it's going to be less than x, negative x. That was going down 1 over 1, so negative 1x. And I don't have to do plus 0 because I already know that if I don't have a whole number, it's just 0, 0. Now this one's going to be greater than because I'm shading to the right. So I have y is greater than, it's solid, so I've got to add that solid line. And I hit at negative 3. So my y-intercept is negative 3. And my slope, I'm going to start here, is down 2 over 1, down 2 over 1. So my slope is negative 2. So I'm going to have negative 2x minus 3. Okay, so which point is the solution for the inequality? Y is greater than negative x plus 3? Well, let's see here. Is 3 greater than 0 plus 3? Because I put a 0 here, it just becomes 0. No, because I don't have an and equal to down here, so it can't be that one. Is 4 greater than 1 plus 3? Negative 1 plus 3, excuse me. Yes, because if I have negative 1 plus 3, that just gives me positive 2. So 2 is less than 4, so this works. Okay, now see, this is in that weird form here. But I'm going to just still do what I did. So my y-intercept is positive 3. Oh, no, that's right. And my slope is 1, 2 over 1. So my slope is negative 2. And my y-intercept is positive 3. So I want to see which one of these is going to make it, and this is a solid line going down to the left. It's going to become less than or equal to negative 2x plus 3. Okay, well, let's see here. If I move this over, well, first of all, I have to find one that's less than or equal to. These are both greater than, so I know they don't work. So I've got to look here. Well, this is the only one that's less than or equal to, so I know it's this one. But let's prove it. If I subtract my 2x over here, this becomes y is less than or equal to negative 2x plus 3, so I know my graph matches. Okay? And which of the following describes the graph 3 is less than or equal to x? The boundary line is dashed? No. I'm going to have to look for something that's solid because it has a solid line under it. It's not A or B. And it's shading to the right? No, it's going to the left because my arrow is pointing to the left, so it has to be D. Okay? So those are like test type questions. You should feel confident in those. Keep going. Which inequality is graphed below? Now since I know this is up and down, it's going to be an x equals because there's nothing over here on the y. So I know that it's not this one, and it can't be that one. So here, I would have to divide by negative 1 on both sides. And when I do that, when I divide by anything, if there's a negative right before that variable, I have to flip the sign. So this becomes x is less than 3. Hey, that works. This is a positive 3. It's dashed because there's no solid line, and I'm pointing to the left. I'm shading to the left just like my arrow. So it's F. Okay, so we're going to graph this system. I have y is negative 2x plus 3. So let me graph that one first. Okay, go back up here. So this gives me y is negative 2x plus 3. I'll go back and look at my sign. And then I have y. So oh, that's less than, okay, 6x plus 6. Okay, so I've got to graph this. I'm going to start at my y-intercept, which is 3, and go down 2 over 1, down 2 over 1. I would put this in your calculator though. And you can still put both lines in your calculator like I showed you on those videos. I'm just going to graph one of these. And this is a dashed line. And it's shading all to the left. Oops. Now I have 6x plus 6. I have 1, 2, 3, 4, 5, 6. And I have up 1, 2, 3, 4, 5, 6 over 1. Down 1, 2, 3, 4, 5, 6. Back 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Back 1, 2, 3. So whatever you get the point, and this one is solid. And this one was shading this way. So I can see that this part is actually what's going to overlap. So, first of all, it asked me, is 0, 0 solution? Sure, yeah, it is. I'm just going to see if the dots that they tell me, or they ask me, are in this shaded area. This goes into 5.6. Yes, because it's in the shaded area. Negative 4 or 5 is not, because it's outside the shaded area. Okay. So you can practice graphing these. I'm not going to do that for you right now. But I did want to show you that none of these flip, so you're good. So let's go back to this one. Same one we got here. Okay, which ordered pair is a solution for this system? Oh, we actually don't have to do that because these are the equal ones, but you would just plug it in. Which system of inequalities is represented by the graph? Okay, so first of all, I need to write both of these lines. So this first line here, I have a greater than because I'm shading this way. So I have y is greater than or equal to because that's a solid line. My slope is up 1 over 1, 2. So it's 1/2 x plus 3. That's my y-intercept. And then I have a y is less than because I'm shading to the left, and there's a dash. I'll leave it like that. Negative 4, and my slope seems to be down 2 over 1. So negative 2x minus 4. So now I've got to see which one of these match that. Well, first of all, I've got to have a greater than going this way, and then I have to have a less than or equal to going that way. So that can't work. This can't work. This can't work because their signs are both with dot lines on. So I'm looking at one of these two. So, first of all, I know this is where I'm going because I won't have to flip any signs here. So I add x over here, and that gives me, I'm going to have to go in the office because I don't want to use my thing. So hold on just a second. Oh, that's why I paused it. I apologize. I did click pause, it just didn't pause. I'm sorry. So I have adding x to both sides. So this would give me 2y is less than or equal to x plus 6. Well, I need it to be greater than. So that's not going to work. Because when I divide by 2 on both sides, that gives me y is less than or equal to 1/2 x plus 3. And I need it to be greater than, okay? So that's not going to work. So I know it's going to have to be this one, okay? So you're just going to have to work through if they're multiple choice. You're just going to have to be able to work through that. But you're still doing the same principles. All right, I'm going to erase that. So which ordered pair is not a solution in this below? Okay, well this is a solid line. Is 0, 0 on the solid line? Yes, so that works. Okay, now I want what is not. I have 0, 3. 0, 1, 2, 3. That is not because it's on the dashed line. So this is the one that would not be the solution. But let's check these others. I have 1, 1. That's in the shaded area, so that works. The overlapping area. And I have 2, 1. That's on my solid line, so that would work. The 0, 3 being on the dashed line does not work. Okay? Now this is what your word problems would look like, because even though the line will keep going negative and shading all the way over there to infinity, this is a real life situation, okay? So I would write this inequality the same way. My y-intercept's 0, 0. My slope is 1, 2, 3, 4, 5 over 1, and it's dashed, and I'm shading to the left. So I have y. I'm going to the left, so I'm going to keep it to the left. No line because it's dashed, and I have 5x. So you're not going to have to make your own real world solution or anything like that, but you could say this isn't relevant to y'all anymore, but calling long distance, I remember when that was the case, it'd be like 5 whatever per minute. So you could say like this is a per minute thing, or maybe they run, she needs 5 teaspoons. She's going to make 3 batches, and it's 5 teaspoons a batch. So how many is she going to need to make for 10 batches of cookies or something like that? Okay. Now, describe the system of linear inequalities to represent each graph. So here, I could write these lines, but these are both dashed, so I have y. The red's going that way, the blue's going this way, so I'm going to start with the blue first. My y-intercept is 3, and my slope is up 1 over 1. Excuse me. So I have x, and I'm shading to the right, so I'm doing greater than x plus 3. And I know the slopes have to be the same, up 1 over 1, because they're parallel. So y is less than x, plus 1. This one's shading to the right, this one's shading to the left. So describe the solutions. Well, all of the ones for this blue line, actually it's only the ones shaded because this is only where it overlaps. So if you go back to that chart on 368, you would say only the solutions between the lines. Okay? If these were solid, you would say the solutions between the lines and on the solid line. But since they're dashed, it's only between. Same with this one, okay? So this is y, and this one's shading down. So this is greater than, because it's shading to the right. Or if I'm going down, I'm getting less, excuse me. That's the weird one. So I have y is less than 3, because I'm at 3 and I'm going down. And then I have y is greater than 1 because 1's my y-intercept, and the y one just goes straight across. There's no slope because I'm not going up or down any. And so here I would say all the solutions between the lines and on the solid line. Okay? And then here, I would say all solutions in the shaded part. So I have here y. Oh, these are solids though, so you gotta put a line underneath. I have y is 3 and it's shading down, so it's less than 3. And here I have my x at -1, 2. So I have x is greater than, because I'm going in the direction of the arrow, or equal to, because it's solid, -2. So you could say all solutions greater than -2, +3. Okay. Now, I'm going to go to this test prep because I think, then I only have one more word problem left to go over with you guys. So, which point is a solution to this? Let's plug it in. 2 times 0 is 0, so plus 0. So is 0 greater than 3? No. So I have 0 plus 1. Is 1 greater than 3? No. Alright, I have 2 plus 0. Is 2 greater than 3? No. But if I have 2 plus 1, 3 is greater than or equal to 3. So that one's the one that works. So which system of inequalities best describes the graph? Well, I am going to have to find the same slope, which I do have. So here I have y intercepts at 1 and then -3. Okay, so we've got 1 and -3 for all of them. So let's see here. Y is greater than 2x and then plus 1, so that one's going this way and it's dashed. So I have that so far and this one so far. So it can't be this one, and it can't be that one because my x is pointing to this way. So now let's see which red one matches. The red is -3, right? And it's going to the left and it's dashed. So it'd have to be this one because they're going opposite ways. Okay. So you could graph these minus the x over here. Give two solutions. Okay, last one is this word problem right here. These are the hardest word problems, and so I felt like it was the best way to do this. Now you could graph these. I think this is the key to number 21. I didn't see this, but there were 3 things we needed to graph, and I think that's where we messed up. Now you can put all 3 of these in your calculator. Okay, get this in y equals form, and you're going to find this. So you can actually use your calculator to do this once you get them in y equals form. So a surf shop makes the profits given in the table. The shop owner sells at least 10 surfboards, that's X, and at least 20 wakeboards per month. Well, since you just have something for X and you just have something for Y, that's why they had to set up separate inequalities. Well, I know that when I graph, remember, I'd have a line straight up at 10, and then I have a Y going straight across at 20. And I can graph that. We had one of those down here, right? And then this is where we set up our normal one. He wants to earn at least $2,000 a month. So if this is profit per board sold, this is where the money is, right? Because I told you money goes with money, amount goes with amount, you have to keep the units the same. So these had to be their own thing because they just want to sell at least that many and at least 20. But when I set up my inequality down here, I'm going to stick with money. So 150x and 100y. And he wants to make at least, so that's going to be greater than or equal than 2,000. So we're going to say, basically they're saying that these can go on forever, but we're just going to look at the positive ones, that quadrant one or whatever. So you can shade beyond that, but your realistic answers have to be in that top right box. Okay, so describe all possible combinations to meet the goals. So the shop could sell any combination represented by an ordered pair of whole numbers in the solution region, like this. Answers must be whole numbers because the shop cannot sell part of a surfboard or a wakeboard. So once I graph the x, once I graph the y, and then I graph that inequality here, okay? They divided all of this by 10 to make it more realistic, if you can't tell, since they all ended in 0. So that made it 15 plus 10y was greater than or equal to 20. So because remember, I can, as long as I do it to the whole thing, I can do that. So I divided by 10, which just took a 0 off. And so that became 15x plus 10y x is greater than or equal to 200. So I guess they did. Okay. And so then I minus 15 on both sides. X minus 15x. And so that became 10y was greater than or equal to 15x plus 200. And divide by 10 on both sides. Divide by 10. That became y is greater than or equal to, now this reduces to 3 over 2, which if you divide 15 divided by 10, math and Rainer, that's what it's going to give you. I just don't have the calculator. And then I just take another 0 off. So it's plus 20. Okay. So they were going, down 3 over 2. Okay, so you put this in your calculator. Put these two things in your calculator. So when you see that this is the only shaded region, you just find two whole numbers for it. And you could use your little cursor in your calculator to do that, or you could go to the table and realize that anything over with a 20y would be fine. So you would go to second graph, and in the table you would scroll all the way down until you saw that y's were bigger than 20, and then pick one of those whole number solutions. As long as the x, so L1 is bigger than 10, and the y is bigger than 20, it's a solution. So you would just go to second graph, and on your table, scroll down for the first whole number solution where x is bigger than 10 and y is bigger than 20. And here it's 15 and 25, so I know that works. Okay? And so like you said, so describe all possible combinations. It's any combination, any whole number combination in the shaded region, in the shaded area, overlapping area, you could even say. They have to be whole numbers because you can't sell partial things. Okay? Alrighty, I hope that helps you. If you have any questions, let me know. I'm going to be checking in with all of you before your test. So I hope you have a great day. Bye.